Our next topic is solving rational equations. Those are equations that have rational expressions or fractions in them. I've got three examples listed here. X over 2 plus 3 over 10 equals x over 5. This equation is, in fact, is something you might see in a beginning algebra text or class because there is no variable in the denominator. But we're going to go beyond that. For instance, the second example, 1 over 3x plus 1 over x equals 4 over 15. Notice the variable is in the denominator. And I've got a third example where the variable is in the denominator as well. Turns out the technique for solving these types of equations is to remove the fractions right from the get-go. And you do that in the same way in a beginning algebra class that you would in an intermediate algebra class. The only difference is that the denominators end up a little more complicated, but it's the same technique. So to remove fractions from an equation, we're going to rely on the LCD, the least common denominator. Well, we've found those before when we wanted to build fractions to a common denominator. We're not going to do that here. We're going to find the LCD, but instead of changing all the fractions to have that LCD, we're going to multiply both sides of the equation, all of the terms, by the LCD over 1. And when we do that, that will actually, when we simplify, remove all of the denominators because they're going to cancel out. The best way to see this is to actually look at some examples. So let's start with an example where the denominators are all just numbers. X over 2 plus 3 over 10 equals x over 5. What we have here is an LCD of 10 because that's the smallest number that all three of these will go into. 2 goes into 10, 10 goes into 10, 5 goes into 10. What we're now going to do is multiply every term in this equation by 10 over 1. So 10 over 1 times x over 2 plus 10 over 1 times 3 over 10 equals 10 over 1 times x over 5. The idea here is that we can, because we're using the LCD, end up simplifying the multiplication here before I do it. When I look at the first term right here, the 10 in the numerator is going to cancel with the 2 in the denominator in the following way. 2 goes into itself once and into 10 5 times. The second fraction, or the second term, the same thing happens except it's even more extreme. 10 goes into itself once and 10 goes into itself once. And on the other side of the equation, 5 goes into itself once and into 10 twice. So I'm able to cancel all of the denominators out. Look closely. My first term now has a denominator of 1, my second term has a denominator of 1, my third term has a denominator of 1. So all I have to do is complete the multiplication in the numerators, and I've got an equation without fractions. So in my first term, 5 times x is 5x. So my numerators multiply, and I just get 5x. And then in the second term, I have 1 times 3, or just 3 in my numerators. And in my last term, I have a 2 left from the cancellation and the x, so that's 2x. So I now have a really nice equation, much simpler. 5x plus 3 equals 2x. It's a linear equation, and we can solve by getting the variables on one side and then dividing to get x by itself. Since I only have one constant term, the 3, I'm going to move the 5x to the other side away from the 3. When I move that, I'm going to change its sign and subtract. 2x minus 5x is negative 3x. Then divide out the negative 3 from both sides. And when we do that, we're going to be left with the value of x. X is equal to negative 1. So it looks like the solution is negative 1. I could also write the solution set in braces is negative 1. We should always check our solutions. So let's squeeze a check in here. Negative 1 over 2 plus 3/10 equals negative 1 over 5. Now in our check, we should never clear fractions. You want to check the check just as it exists. So check the equation. So on this left side, I would want to get a common denominator. So negative 1 over 2 would become negative 5/10 for 1/2. And then when I add that to 3/10, I'm going to get negative 2 over 10, which simplifies to negative 1/5. Remember, the goal when we are looking to check is that the left side equals the right side, and we do find that. So this answer does check. Our second equation has more interesting denominators in that there's x involved. Remember how we find an LCD when we have x involved. What we're going to do is start with the first denominator and then include anything from the second denominator that is new. Well, we already have x. And then we want to include anything from the third denominator that's also not there. Well, 15 is 3 times 5. We already have the 3, so we want to include the 5 there. So 3x times 5 is 15x. It turns out that last denominator is part of the common denominator with the x, 15x. We're going to take that common denominator and multiply every term by it. 15x over 1 times 1 over 3x plus 15x over 1 times 1 over x equals 15x over 1 times 4/15. Cancel denominators. So 3x will cancel and go into 15x 5 times. X will cancel with just the x, not the 15, and the 15 will cancel but not the x in the last fraction. So when we look at what we're left with, we have 5 times 1, just 5 in that first term. In the second term, I'm going to have 15. And in the third term, I still have an x left. It's 4x. Simplifying, 5 plus 15 is 20, equals 4x. And just divide out the 4 to get the x by itself. 20 divided by 4 is 5. So it looks like our solution is 5. We should check that to make sure. So to check this, we're going to put it back into the original equation. 1 over 3 times 5 plus 1 over 5 equals 4/15. Remember, we want to check the left and the right side separately. So what I mean by that is we want to calculate them separately. So starting with the left, 1 over 15 plus 1/5. We need a common denominator to add those. 1 over 15 plus 1/5 would be 3 over 15. And then add those together, 4 over 15. Notice that's exactly what I had on the right side, so that checks. One thing to note is that it's really important to check these rational equations because just that rational expressions have restricted domains and equations will have restrictions as well. So some values that will not or are not allowed to be solutions. In this case, we saw that both of these equations had a single solution and they worked, but always check. Let's solve that third equation we had in our 3 examples. 5 over x minus 2 plus 2 equals 4 over x minus 2. Here we have 3 terms, 2 of which are fractions, and they have the same denominator. So the LCD would just simply be that single denominator of x minus 2. That's the same for both of those fractions. And we want to multiply that on both sides of the equation. And remember, all terms. So even though the second term on the left side is not a fraction, we still need to multiply by it, because the rule of equality says you have to do the same thing to all sides. So I'm going to multiply the first term, 5 over x minus 2 times x minus 2 over 1. And I also have to multiply the second term by x minus 2, the common denominator. Now I don't have to write this over 1 in here because it's not a fraction, so I don't need to actually write it over 1 to multiply it by a whole number. And on the other side, 4 over x minus 2 times x minus 2 over 1. Now one thing you'll note is that in this first term, I multiplied the LCD over 1 on the left side of the first term. And in the other 2 terms, I multiplied on the right side. It really doesn't matter. It's just how I happen to write it down. It's your choice whether you multiply the LCD over 1 on the left or the right side of each term, but you have to do it to all 3 terms. Let's simplify. In our first term right here, we have x minus 2 in the denominator. It cancels with x minus 2 in the numerator. So, and remember, when you cancel, you're left with 1. But altogether, that means I've got 5 over 1, or just the term 5. Plus, I've got 2 times x minus 2. I can do that distribution while I'm writing things down. 2x minus 4 equals, and then in my last term here, the x minus 2's again cancel. This time I'm left just simply with 4. So I have an equation with no fractions anymore. 5 plus 2x minus 4 equals 4. Collecting like terms, that's 2x plus 1 equals 4. Subtract the 1 from both sides and I get 2x equals 3. Divide out the 2 and I get x equals 3/2. So the solution, if I've done this right, is 3 over 2. We should check that to make sure we haven't missed anything. So when I put a 3 halves in to the left and the right side of the equation, I'm going to get 3 halves minus 2 in the denominator with 5 in the numerator, plus 2 on one side of the equation, and on the other I get 4 over 3 halves minus 2. Now here we have fractions within fractions. Just take your time simplifying each fraction independently. We're going to do the left and the right separately. So we have 5 over, do the subtraction there, 3 halves minus, we need a common denominator, 2 is the same thing as 4 over 2. So that's going to be 3 halves minus 4 over 2, which is negative 1/2. 5 divided by negative 1/2. Remember, when you have a number divided by a fraction, you flip and multiply. So this is 5 times negative 2 over 1, or just negative 2. We still have the plus 2, and then 5 times negative 2 is negative 10, plus 2 is negative 8. So we've got negative 8 on the left. On the right, let's follow through with the calculation. 4 over, well, 3 halves minus 2. 2 is 4 over 2. This denominator ends up being the same thing I did over on the left. 3 minus 4 is negative 1/2. And remember, when you divide fractions, you flip and multiply. So this is 4 times negative 2, or negative 8. So we get negative 8 on both the left and the right. So this was my solution.